Let's go ahead and finish up our test review that we were working on yesterday. Yesterday we got through questions 1 through 9, and today we'll finish up with questions 10 through 20. What I would like to help us out with the first set of questions for numbers 10 through 13 is if you will go ahead and open up your textbook to page 424. We're going to look at example 66.2 together. Now, what I'm going to have you do from questions 10 down through 13 is to write some equations of our sine and our cosine graphs where they had both a phase angle and they also had that period change. On the top of the test on this section, I have the format that you're going to have to follow in. So at the top here, it says y equals dotted line plus amplitude, sine, cosine, and then period, and then inside the parenthesis, theta plus or minus the angle. So that information will be right there on the test. You just have to go ahead and fill it in on your question. All right, so let's walk through what we have here on this problem. The first thing that I need on example 66.2 is going to be the dotted line. Now, the dotted line on that question is not labeled for us, so we're going to have to go ahead and pick it out for this question. On the test, I will make sure that the dotted line has been labeled for you, and the dotted line here is going to be the number 3. The dotted line, it's the average of the high and the low point, so 7 and a negative 1 is 6. And then half of 6 is 3. So that's why the dotted line was located at 3. It's 4 spaces away from both the high and the low point. So then we have our plus sign. The plus sign was always the next sign, and I have that on the format that you're going to follow. The next thing that you're picking out was the amplitude. Well, we just identified the dotted line was 3. So going from 3 up to 7, how many spaces was that? It was the number 4. And we could do the same thing going from 3 down to negative 1. It was the number 4. On the directions, and this will be like numbers 10 and number 12, is going to say to write it as a sine graph. Numbers 11 and 13 are going to do a cosine graph. So you'll be using one picture, just like we're doing here, to answer 2 questions. Then you'll use a second picture to answer the next 2 questions. Well, after we write down sine, which again is given to us, we have to pick out the period. Remember, the period is the rotation. The normal rotation of our sine as well as our cosine graphs is 360 degrees. Well, if I take a look at this picture, however, it's not rotating at 360 degrees. How did we come up with the new rotation? We had to find 2 locations on the Cartesian plane where the exact same thing is happening. If I look at my picture, I notice that my graph is headed up through the dotted line at negative 225, and it's also headed up at 315. How far is it from negative 225 over to 315? That's 540 degrees. So in order to find the period that goes in front of our parenthesis, we took the normal rotation, which was 360, and we divided by the new rotation. So 360 divided by 540, that reduced down to 2 over 3. Now, I didn't have to use the 2 angles that I just picked out for us. We also could have used negative 90, which was at the top of the hill, as well as 450. That was another top of the hill. So how far is it from negative 90 over to 450? It's still 540 degrees. And 360 over 540 still reduces here to 2 over 3. Now you're ready to work on the parenthesis. Inside of the parenthesis, we always start with theta, and I have that written on the test for you. You had to make a decision on the plus minus sign as well as the angle. Well, since we're dealing with our sine graph, what was the angle for a sine graph? It was the point closest to the origin where it was headed up through the dotted line. On my graph, I see 2 different locations where the graph is headed up through the dotted line, and that was at negative 225 as well as positive 315. Which one of those is closer to the origin is the negative 225. However, because I'm putting it inside parentheses, I have to put the opposite. So I put theta plus 225. Now, what's nice, we're now ready to write the cosine question, and the cosine answer is identical except for 2 pieces. Remember, the 2 pieces we're going to switch out. We're going to change sine to cosine, and then we're going to change the angle. So the first part of my answer is still identical. Y equals 3, because that was the dotted line, plus 4, that was the amplitude. We're now doing the cosine graph, so I filled in cosine. The period was still 2 over 3. or 360 over 540. Inside the parenthesis, here's another change that we're going to make. What were we looking for when it came to our cosine graph for the phase angle? We were looking for the point closest to the origin where it reached its highest hill. Where do I see closest to the origin, the highest hill? It's at -90. So therefore, inside of the parenthesis, I put +90 to finish up our question. All right, so again, you'll face two different graphs here. You'll answer 10 and 11 out of the first graph and 12 and 13 out of your second graph. All right, continuing here, we're now looking in lesson 66 as well, so same idea here with the same lesson. The next thing that you'll be answering for me was the formulas that we had in our systems of equations. Now, the first two questions that you did on the test for me, you were solving an abstract system just to answer. This was the abstract answer for x, this was the abstract answer for y. Well, then what we did here in lesson 66 was we came up with a formula for x, we came up with a formula for y, and then using those formulas, we were able to correctly solve a system. So again, on questions 14 and 15, they're going to be grouped together. You'll use the same system to answer both questions. So the first thing that you'll be answering for me is the x. So if you remember from lesson 66, the x formula that we had come up with, and I did put this on the test for you, it says B2C1 minus B1C2 all over A1 B2 minus A2 B1. So that's written there for you. You just have to correctly fill it in. So in the numerator, it says B2. Well, the B on the second equation was the -4. Remember, the letters went in order, A, B, C. So -4 times C1. So from the first equation, the C is the number 6. And then minus B1, the B from the first equation was the number 2, times C2. From the second equation, the C was the number 12. Filling in the denominator. A1 was the number 3, B2 was -4, minus A2, which was 2, times B1, which was the number 2. Now it's just a matter of doing my arithmetic. -4 times 6 was -24. -2 times 12 was -24. In the denominator, 3 times -4 is -12, and then -2 times 2 is -4. Collecting our terms here, -24 minus 24 is -48, and -12 minus 4 is -16. Finish out dividing. This one divides out evenly, and I know that x is now equal to 3. So that's like question 14. Now in question 15, you'll use the exact same problem, but now you'll be solving for y using the formula that I have on the top. Okay, so the formula says A1. So I picked the A from the first equation, that was my 3, times C2, or 12, minus the A from the second, which was the number 2, times the C from the first, 6. All over the A from the first, 3, B2, that was -4, minus A from the second was 2, times B from the first, which was the number 2. Now, do notice on these two questions, the denominator is the exact same. They both say A1B2 minus A2B1. So whatever you filled in the denominator for x should be the same setup that you're using for the y in your question. All right, so let's multiply. 3 times 12 is 36. -2 times 6 is -12. In the denominator, 3 times -4 is -12, and then -2 times 2 is -4. Subtracting next. 36 minus 12 gave me 24. -12 minus 4 is -16. Now this question, as opposed to the x, this one does not divide out evenly, but I need to reduce my fraction. 24 and 16 both divide by 8, and I'm just going to fling the negative up to the top, and I would say -3/2. If you wanted to write that as a mixed number or decimal, it's okay. I would just suggest you leave it as the improper fraction. You just reduce it in your question. All right, so that takes us through questions 14 and 15. We have 2 more sections to finish up, and you'll want to use your calculator here on the next question. This was out of lesson 67, where we talked about our anti-logarithms. Remember, a logarithm was an exponent. The anti-logarithm was the number or the answer to your exponent question. I had to give you the base, I had to give you the exponent, we typed them on the calculator, and that was our final answer. So you'll face 3 questions like this. Should be a pretty easy section for you to do. Find the anti-logarithm of 5.31 if the base is 10. So how do I put that into the calculator? What does the base tell me? It says it's 10. The other number has to be the exponent because the anti-logarithm is the number using this exponent. So 10 to the 5.31 power, and my final answer was 204,173.79. We'll go ahead and round those to the nearest hundredth, so 2 places to the right of our decimal point. One more example with our anti-logarithm, the one that had the base of e, just so we remember how to do that on our calculator. So find the base e, anti-logarithm of 1.28. So how do I put that on my calculator? E to the 1.28 power. That's a specific button that I have on my calculator, so make sure you know where that was located. So E with my exponent of 1.28 gave me approximately 3.6. If I remember correctly, when I did this the other day, it was like 3.596 or something. So it rounded all the way up to 3.6 for my final answer on this question. All right, last section, and this is what we talked about out of lesson 69 with regard to our matrices as well as our determinants. What I'm going to have you do to finish up your test from questions 19 and 20 is you're going to find a determinant from a 2 by 2 matrix. Remember, the determinant is where I had to cross multiply. Just don't forget, as you're coming down in your cross multiplication, you write the exact same answer you get. But as you came up in your cross multiplication, we had to put the opposite. So I just have one example that we'll finish up with here today to finish our test review. So your question is going to look like this. Across the top row, -4 and -6. Across the bottom row, 5 and 2. In order to do the determinant, as I just mentioned, we're cross multiplying. So the first thing I'm going to do is -4 times 2. -4 times 2 is -8. I wrote down the exact same product that I got. Go in the other direction. I'm going to take 5 times -6. 5 times -6 is -30. However, because I went up in the question, I had to put the opposite, so plus 30. The reason we were putting the opposite was because the formula said minus that product, while subtracting a negative goes into a positive. So it's going down, same number, coming up, the opposite of your number. Finish out with adding. -8 plus 30 is 22. All right, so that covers our test review. Make sure that you do look over these topics, and I think you guys will be good to go on test number 10.